Hello there, this is Mark Wardle. I just wanted to give you a really quick demonstration of a tiny SNOMED CT open source microservice called Hermes. If you go to my blog, www.wardle.org, it's this post from July on data analytics using SNOMED CT. I've set up a $3 a month demonstration server. It's a tiny server, 256 meg of RAM, but it works. It could be faster if I gave it more RAM, but it works. So this is the server address. If you click on that, it's fast actually, but it could be even faster. This basically gives me information about this concept here. So this is multiple sclerosis. That's the core data regarding multiple sclerosis. You can get a list of descriptions, you can get the ref sets for which it belongs, and that's the detailed ref set identifiers. And if you just want everything kind of denormalized, which is normally what you want, then you just use extended, and that gives you an optimized denormalized version of this. Gives you the descriptions. It looks at the locale requested in the HTTP headers, and asks whether each description is preferred or acceptable in that. At the bottom it will give you the preferred description in the current locale, ref set membership, but also transitive closure tables, so you can easily do tests of subsumption based on the type. So this is so is this a type of demyelinating disease of the central nervous system? Yes, it is, but you don't need to do like 16 different back and forth server round trips. You just look at the NAT and you say what this is. We can ask for this in different formats. This is just JSON. If you ask it for a data exchange format that actually has first class sets in it, which some data interchange formats do, then this will come back as a set, so you can really quickly check for that. So that's that. There's an autocomplete service, so that's called search, and we can just use that to power an auto-completion service. So say our user is typing MND, it's going to pop up like that. And if you're going to type in, say, for example, multiple sclerosis, then you're going to get all of that. But that's fine, but normally you'd want to constrain that. So this is going to be everything with multiple sclerosis in it. You're going to want to constrain it to types of, say, diagnosis or clinical finding or other parts of SNOMED CT. The easiest way of doing it, you could search using this. So you could say, well, actually, I want to constrain to a type of occupation. So we can take that and then say, okay, the user is starting to type neuro, and then I'm going to constrain it using. So I suppose if I do that, that doesn't make any sense at all. So imagine you are driving an autocomplete pop-up for occupations in your EPR. So the user is starting to type neuro. Well, you're going to constrain that using Ecl, the SNOMED CT expression constraint language. This is fully implemented in this open source tool. So we go Ecl is, and then a subtype of, and then we'll paste that occupation in, and suddenly you've only got things beginning with neuro. And so you can do it like that, or you can just go to a graphical terminology browser, which is provided by SNOMED CT, SNOMED International, and there's one for the UK from NHS Digital. So say you were doing that, you could type this in, occupation, and then you get it's a bit slow. So so you get that code. So that tells you what you want to do. Say, for example, you were interested in expanding an Ecl expression. So instead, you could just go expand. So this doesn't work for large parts of SNOMED CT because you're going to like expand the whole expression. But the system works actually. JSON viewer here can't cope with the size of the number, but if you really wanted to have a big pop-up, you could. I would normally not do that unless I know that the expansion isn't going to be too large, but you can do that. There's lots more in there. There's documentation online. If you go to the GitHub website, github.wardle.hermes, you can read all about it. There's some documentation here. you can download a distribution manually and import it, or if you're a UK user and you have a TRUD API key, then you just run that and it will run your, it will download it automatically, install all the data, and then give you a terminology server within about 10 minutes. All you need to do is clone the repository. You don't need large elastic cache servers, or and you can just run a microservice, run multiple services, load balance across them, and deal with historic data just by running different services using different distributions. Thank you very much.